As months passed, Allied commanders learned to counter the threat. They began attacking airfields before jets could climb to safety, circling overhead to catch them on approach. Conventional fighters, though slower, waited like predators near runways. Losses among the limited jet squadrons mounted. Despite their fearsome reputation, the Me-262s could not appear in numbers large enough to alter the air war's course in the closing years of the Second World War. The skies over Europe were crowded with propeller-driven aircraft locked in a daily contest for survival. Allied bombers poured toward German cities in endless waves, while swarms of fighters dueled above them in tangled spirals of smoke and fire. For almost the entire war, speed was predictable. Engines roared, wings shuddered, and air battles played out at a few hundred miles an hour. Then, seemingly without warning, something new appeared, sleek, silver, and fast enough to leave the familiar rules of air combat in ruins. It was the Messerschmitt Me-262, the world's first operational jet fighter, a machine so advanced that pilots who faced it described it as if it had come from another world. The story of this aircraft began years before it ever touched the sky. In the late 1930s, engineers across Europe were chasing the dream of jet propulsion. In Britain, Frank Whittle experimented with turbine engines that promised to eliminate propellers altogether. In Germany, a young engineer named Hans von Ohain worked quietly in a laboratory, convinced that a gas turbine could produce unprecedented thrust. His early prototypes caught the attention of aircraft manufacturer Ernst Heinkel, who saw potential in the new technology. Together, they produced the He-178, the first aircraft to fly purely on jet power in 1939, a remarkable proof of concept that demonstrated the future had already arrived. Even as most militaries still relied on biplanes and piston engines. But within Germany's complex web of aircraft companies, rivalries ran deep. Willy Messerschmitt, whose Bf-109 fighters dominated the early war years, saw jet propulsion as a chance to redefine air superiority. He proposed a design built around two jet engines under swept wings, an aircraft that could outrun and outclimb anything in existence. Early sketches looked like something from a science fiction magazine. Minimal drag, pointed nose, heavy cannon armament, pure speed. The concept received approval from the Air Ministry, and the Me-262 project formally began in 1938. Progress, however, was slow. Jet engines were temperamental, fragile, and prone to catastrophic failure. Materials that could withstand their heat and stress were scarce. Each test run destroyed precious parts. Engineers wrestled with compressor blades that warped, bearings that seized, and flames that erupted from exhausts without warning. Wartime shortages of high-temperature alloys meant improvisation, and improvisation meant danger. The aircraft itself had to be redesigned repeatedly as engineers learned, often the hard way, how much power those early engines could generate. By 1942, a prototype finally managed to leave the ground, assisted by a small conventional engine in its nose. The sight of the aircraft lifting off on a plume of pure jet thrust stunned even veteran pilots. It was faster than any fighter the Luftwaffe possessed, climbing to altitudes that Allied aircraft could barely reach. But new problems surfaced immediately. The engines lasted only a few hours before failing. Fuel consumption was enormous. Landing speeds were terrifyingly high. Every test flight risked disaster, and each success came at the price of another burned-out turbine. While engineers struggled to tame the new technology, the war outside moved relentlessly on. The Allies gained strength, launching larger and more frequent bombing raids on German industrial centers. Entire cities disappeared under walls of flame. Within Messerschmitt's hangars, the pressure to deliver a miracle intensified. Test pilots spoke of an aircraft that could end the raids, but bureaucrats hesitated. The design was revolutionary, and revolutions rarely fit neatly into production schedules. Still, reports from those few who had flown the jet hinted at its potential. One pilot claimed he could overtake an Allied reconnaissance plane with ease, climbing past it like a hawk diving through pigeons. Another described the eerie silence compared with the throbbing roar of piston engines, the jet's smooth, continuous howl that built to a piercing shriek as speed climbed beyond 500 miles an hour. For the first time, the boundaries of the air war seemed negotiable. At high command, however, priorities shifted. Some leaders wanted the aircraft turned into a bomber, believing that new, lightning-fast strike planes could retaliate against Allied cities. The engineers protested. Every modification delayed the program further. Meetings turned tense, papers were stamped, and the project lost months as new bomb racks and sites were tested. By the time production cleared those hurdles, the Allies were already landing in Normandy. In the summer of 1944, operational squadrons finally received their first Me-262s. The aircraft looked like nothing else in the sky: sleek fuselage, thin wings, tricycle landing gear, and twin jet nacelles that glowed dull orange at takeoff. On the runway, the engines needed long, delicate spooling before producing full thrust. Pilots learned never to move the throttles too quickly. A careless push could cause a flameout or even explosion. But once the turbines steadied and the brakes released, acceleration pinned the crew back in their seats. The aircraft roared forward, lifting into the air with a smooth surge that conventional fighters could not match. When Allied airmen first encountered the jet, disbelief spread through radio channels. American bomber crews reported a comet-like object streaking through formations, firing 4 heavy cannon rounds before vanishing. Escorts tried to pursue but found themselves left behind as if standing still. The Me-262 could dive, climb, and escape at will. Veteran pilots described it as a glimpse of warfare's future, a weapon far beyond anything fielded before. Yet for all its raw power, its impact remained limited. Every sortie demanded hours of maintenance. Spare parts were scarce and airfields were under constant attack. Jets needed long runways, making them easy targets during takeoff and landing. Fuel shortages grounded many squadrons before they could fly. Some aircraft never left the factory floor as raids destroyed assembly lines. Despite the plane's breathtaking performance, the industrial machine that sustained it was collapsing. Those who did fly the Me-262 became both test pilots and frontline soldiers. They adapted new tactics on the fly, diving from above bomber formations, firing quick bursts, then escaping before escort fighters could react. The aircraft's heavy armament could shatter a 4-engine bomber in seconds, but precision was difficult at such speed. Pilots often had only moments to aim before flashing past their targets. Every mission was a balance between aggression and survival, between exploiting the jet's speed and protecting its fragile engines. As months passed, Allied commanders learned to counter the threat. They began attacking airfields before jets could climb to safety, circling overhead to catch them on approach. Conventional fighters, though slower, waited like predators near runways. Losses among the limited jet squadrons mounted. Despite their fearsome reputation, the Me-262s could not appear in numbers large enough to alter the air war's course. Inside Germany's research centers, engineers kept refining the design: stronger turbines, lighter materials, even rocket-assisted takeoffs, but time had already run out. The same factories that built the jet were now targets themselves. The innovation meant to restore air superiority became instead a symbol of what might have been a technological leap achieved amid chaos. By the war's final months, hundreds of jets sat unfinished in hangars scattered across the country. When Allied troops reached those airfields, they found futuristic shapes half buried under debris, their metal surfaces scorched by retreating crews who destroyed what they could. Yet even in ruin, the silhouette of the aircraft commanded attention. Engineers from every victorious nation examined the wreckage, realizing that the age of propellers was ending forever. The Me-262 had introduced the world to jet combat. It proved that turbines could lift heavy fighters faster than any piston engine, that aviation's next frontier had already been crossed in the darkest years of conflict. Though its role in the war was small, its influence on post-war aviation was immense. The design studied by Allied engineers directly inspired the next generation of jets: the British Meteor, the American P-80, and countless others that would define the Cold War skies. In that sense, the aircraft became more than a weapon. It was a warning from history about innovation born under pressure, a glimpse of humanity's capacity to push technology forward even while the world burned around it. The Me-262 remains a machine of contradictions, brilliant yet flawed, advanced yet fragile, a triumph of engineering that arrived too late to change fate. When the sound of jet engines faded from the ruined airfields of Europe, a new race quietly began, one that had nothing to do with dogfights or bombing raids. Engineers from the victorious nations swarmed over the captured Me-262s, measuring, photographing, and sketching every inch. To them, the aircraft was less a defeated enemy than a time machine, an artifact from a future that had arrived early. American, British, and Soviet teams dismantled examples and shipped them home. In workshops far from the front lines, technicians studied the alloy composition of turbine blades, the shape of the swept wings, the arrangement of fuel pumps and compressors. Every discovery seemed to whisper the same message. Aviation would never be the same again. For pilots who had fought against it, memories of the jet carried a mixture of fear and admiration. Allied crews told stories of silver flashes streaking through bomber formations so fast that gunners could hardly swing their turrets before the attack was over. Debriefing officers noted the disbelief in their voices, a grudging respect for the skill it took to fly such a temperamental machine. Many later admitted that facing the Mi-262 had been like confronting the next century. Even stripped of its wartime context, the aircraft embodied the dangerous beauty of technological leaps made in desperation, lie recruited into foreign research projects. A handful later worked in the United States under the new aerospace initiatives that would lead to early jetliners and back in the shattered towns of Germany. The few surviving engineers of the program faced an uncertain future. Some were questioned by occupying forces, others quiet supersonic fighters. The irony was hard to ignore. The same minds that once struggled to defend a collapsing regime now helped lay the foundations for peaceful air travel and exploration beyond the atmosphere. Technically, the Mi-262's influence was immediate and profound. Its engines, though unreliable, taught the world what was possible with axial flow turbines. Its wing design, with a subtle sweep to delay compressibility effects, foreshadowed the high-speed aircraft of the 1950s. Even its tricycle landing gear, unusual for fighters of the era, became standard as speeds increased and visibility on takeoff grew critical. Every modern jet owes something, however small, to the lessons learned from that machine's successes and failures. Yet the legacy of the Mi-262 was not purely mechanical. It also served as a cautionary tale about how innovation can be distorted by urgency. Within the German program, the obsession with producing a war-winning miracle created endless delays and compromises. Engineers were forced to satisfy contradictory orders, torn between building a fast interceptor and a jet bomber. Time that might have been spent perfecting the engines was lost to redesigns and bureaucratic interference. In the end, the technology reached the battlefield not as a decisive weapon, but as a symbol of mismanaged brilliance. That contradiction continues to fascinate historians. How could a nation capable of producing such advanced machinery fail to use it effectively? The answer lies partly in scale. The jet's production numbers never matched the thousands of conventional aircraft the Allies fielded. But there is also a human dimension. Every innovation demands patience, testing, and refinement, luxuries a collapsing regime no longer possessed. The Mi-262 proved that a revolutionary idea alone cannot overcome exhaustion and chaos. For the pilots who flew it, however, the aircraft was unforgettable. Surviving veterans spoke later about the sensation of speed, the smooth, almost effortless climb, the sense of power that came from leaving propeller-driven planes far below. But they also remembered the loneliness of those missions. Few could accompany them. Most of their comrades flew older machines that could not keep pace. Every takeoff felt like an experiment, every landing a gamble. A single engine failure could mean disaster. Many who trained on the jet never lived to see combat, victims of malfunctions rather than enemy fire. As the war receded into memory, the Mi-262 acquired a new identity. Museums around the world began restoring surviving examples, polishing their aluminum skins until they gleamed under spotlights. Visitors today often stand silent before them, sensing both awe and discomfort. The aircraft is beautiful, sleek, balanced, and unmistakably modern, but it carries the weight of the era that produced it. Its curves tell a story not of triumph, but of tragedy, of human creativity pressed into service for destruction. Modern aviation engineers still study its form. In wind tunnels and computer simulations, the old design continues to teach lessons about airflow, stability, and structural efficiency. When test pilots fly replicas built from original blueprints, they describe the same thrill their predecessors felt 80 years ago. The aircraft leaps forward smooth and powerful, as if eager to remind the world that it was once the cutting edge of human invention. Looking back, the Mi-262 stands at a crossroads between two worlds. Behind it lay the age of propellers and fabric-covered wings, the familiar rhythm of piston engines. Ahead stretched the vast horizon of the jet age, the Cold War fighters, the supersonic transports, the spacecraft that would break Earth's bounds entirely. It was a bridge between desperation and discovery, an invention that transcended the circumstances of its birth. There is a strange justice in the way its legacy unfolded. The very technology designed to dominate the skies of war became the foundation of peaceful travel. Jet engines carried passengers instead of bombs. Swept wings lifted airliners instead of fighters. The same principles that once sought speed for survival now offered connection and exploration. In this transformation lies one of history's quiet redemptions, the ability of science to outlive the purposes it was first meant to serve. Today, when people hear the steady roar of a commercial jet climbing into the sky, they are hearing an echo of that first leap into the unknown. The Me-262's pioneering turbines, crude and fragile as they were, opened the door to the modern world. Every airport runway, every contrail drawn across the atmosphere, traces back in some measure to those experiments conducted amid war's destruction. The story of the jet is therefore not only about conflict, it is also about the resilience of curiosity and the persistence of progress. In the final analysis, the Me-262 was both a marvel and a warning. It demonstrated what happens when engineering brilliance outruns the ability to use it wisely. It showed that even the most extraordinary invention cannot reverse the course of events when deployed too late. Yet it also affirmed that knowledge itself is neutral. It can serve darkness or light, depending on who wields it. The aircraft remains preserved in museums, its engines silent now, but its legacy alive in every modern plane that crosses the sky. Visitors who look closely at its twin nacelles and slender wings often find themselves imagining the sound of those early turbines spooling up, the shimmer of heat on the runway, the moment when the future first lifted off the ground. For an instant, one can almost see what those wartime pilots saw, the horizon racing toward them, the air itself trembling with new power, and then the vision fades, replaced by the quiet hum of the present day. The lesson endures, that innovation once born cannot be contained. The Me-262 proved that the boundaries of human achievement expand even in the darkest times. It stands as a testament to the complicated relationship between technology and morality, between progress and purpose. In its metallic frame lie both the shadows of history and the light of what was yet to come.